Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on machine learning. Today we are mainly discussing about on gradient descent boosting. It is one of the supervised learning technique in our machine learning. By using supervised learning technique, the prediction can be made. The gradient descent boosting, the mainly training and also prediction mainly follows this boosting technique. Okay, let us discuss the background of the ensemble techniques. Ensemble techniques are two types: bagging or bootstrapping aggregation, and second one is a boosting. Bagging or bootstrapping aggregation is a parallel process. Boosting is a sequential process. Okay, let us discuss how the training and also prediction by using the bagging or bootstrapping aggregation here. Okay, let us take the 1,000 records as the example. From this 1,000 data records, random 700 records we have taken for the original training data. This original training data we are dividing into the multiple data sets in our step 1. Data set 1, random 400 records we have taken from this original 700 training data, and that we are mentioning it as data set 1. Similar way, data set 2, random 420 records we have taken from this original training data from this 700 records, that we are mentioning it as data set 2. Similar way, data set t minus 1. Similar way, data set t. And after that we need to apply either classifier or regressor based on this data set. If the data set, the target data is categorical or binary, we need to apply the classifier. If the target data is continuous, then we need to apply the regressor. Okay, based on the data set we will apply the classifier or regressor. Similar way, based on our data set we will apply classifier or regressor. Similar way, based on our data set we will apply the classifier or regressor. Then finally we need to combine our all the results. In case of classifier, let us take the four classifiers. For example, classifier 1 I got the prediction as true, and classifier 2 I got the prediction as true, and classifier 3 I got the prediction as true. For the classifier 4 I got the prediction as false. Which is having highest vote, that I am selecting as prediction in our classification model. In case of regression model, for example, the regressor 1 I got prediction as 10, regressor 2 I got prediction as 20, regressor 3 I got prediction as 30, regression 4 I got prediction as 40. Then we need to add all the results and we divide by 4. We need to aggregate all the results that we are taking it as prediction. This is a way the mainly training and also prediction by using this bagging or bootstrapping aggregation. Then let us discuss more on the boosting technique. Why? Because this gradient descent boosting always follows this boosting technique. It is like a sequential process. In the first iteration, I'm just passing the 10 records. Out of 10 records in the first iteration, only 3 records are classified as correctly, and other 2 records are classified incorrectly as a red. Okay, here these two are misclassified in the first iteration. Then I am going to target these two in the next iteration. That's why I'm drawing a line here. These two records are classified correctly, but other 3 records classified as red. These 3 are misclassified in the second iteration. I'm going further iterations. Okay, here I am drawing a line here. I classified all the blue records exactly, but other red records I classified as blue. Okay, these 4 records are misclassified in the third iteration. Okay, if I calculate the efficiency of the first record, let us take 30%. The second record, for example, second iteration, I got 30%. Third iteration, I got 30%. If I combine all the results, then I will get around 90% of the efficiency. Okay, here I am just combining all the weak learners into the strong learner. Okay, this is the way mainly the boosting technique will work. Okay, let us discuss more on the boosting classification today. This regression problem already we discussed in the previous session. Okay, today we will mainly discuss about on this classification problem. Okay, here the mainly gradient boost can solve both the classification problems and also regression problems. Today mainly we'll take one example data set, then we'll see how we'll train and also how we'll see the prediction. Okay, now we'll see the one data set here. Here in this data set contains three independent features, one dependent feature. Okay, here in x1, x2, x3, three independent features, and y is my target. If the target data categorical or the binary data, then we can apply our classification model. Okay, here mainly our logistic regression we are using the mainly to calculate the residuals. We are using the mainly logistic regression. In the step 1 we need to calculate the log odds. Okay, this is a log odds formula: log e p divided by 1 minus p. Here I need probability from this target data. Here I am calculated the probability. Probability equal to 6. How many ones here? 6 ones divided by out of 10, out of 9. That's why I just mentioned my probability 6 divided by 9. If I calculate the log of 6 divided by 9 divided by 1 minus 6 divided by 9, just I replace the probability here. Just let us assume I got the zero point 0.7 as my base prediction. Okay, now I got the log odds. Now I need to convert log odds into the probability using this formula. This is my sigmoid function in our logistic regression. E power x divided by 1 plus e power x. This is my logistic regression. Just this x I replaced here, e power zero point 0.7 divided by 1 plus e power zero point 0.7. Then I calculate, I got zero point 0.7 prediction. This is my model 1 prediction. Now we need to calculate the residuals. Okay, I got the prediction as zero point 0.7 for all the records, and I need to calculate the residuals now. Actual minus prediction. Now I will get the residuals. 0 minus zero point 0.7 minus zero point 0.7 is my residual. Similar way, 0 minus zero point 0.7 minus zero point 0.7 is my residual. 1 minus zero point 0.7 zero point 0.3. For all the records the same. 0 minus zero point 0.7 zero point 0.7 minus zero point 0.7. Okay, these are my model 1. I am just representing my model 1 here. This is my x1 is less than 20. This is my x less than 20. Let us just see the only for these three records. Okay, here let us just select the only three records, then we'll understand. Okay, model 1. Okay, here less than 20, x1 is less than 20. Now x2 is high, x2 is high. What is my residuals? Zero point 0.7, zero point 0.7. Just I mentioned my leaves as 0 0.7, 0 0.7. This 2.7. Okay, next less than 20, and my x2 is L. X2 is L means zero point 0.3. This is my zero point 0.3. I mentioned it as here the second leaf. And we'll go further. And 20 to 30, let us take the, this is complete all 20 to 30. Okay, this all the records are 20 to 30. Okay, this 20 to 30, these three records, this is a model 1. Until here they are model 1. Okay, here this 20 to 30, I mentioned all are zero point 0.3. My residuals are zero point 0.3. This is a 23. My leaves are here, my leaves. This is a one leaf, this is another leaf, this is another leaf, another leaf, another leaf. Okay, these are the all the leaves. Okay, here this for the three records I mentioned it as zero point 0.3. This zero point 0.3, zero point 0.3, zero point 0.3. Similar, if the greater than 0, here until residual only we need to select. Okay, here greater than 30, x1 is greater than 30. Now we need to interested about on x3. X3 is e, x3 is e means minus zero point 0.7, and if the x3 is f, zero point 0.3. Okay, just I mentioned whatever my leaves here, leaves as residuals. Okay, here I just mentioned all the residuals here. Here residuals for the all the leaves, I just mentioned the residuals here. Okay, let us calculate the now weight of the each and every leaf. Okay, here this is a weight formula for the calculating the for the leaf. Okay, here residuals of the leaf. Okay, here summation of residuals of the leaf divided by summation of previous probability. This is my previous probability multiply 1 minus previous probability. Zero point 0.7 multiply 1 minus zero point 0.7. Okay, here I need to sum for the all the samples, all the residuals. For example, residual 1 minus zero point 0.7. For the second residual I need to sum it all the residuals plus minus zero point 0.7. Okay, for the numerator I got for the first leaf, and the denominator here sum of first for the first residual, for the first prediction is zero point 0.7 multiply 1 minus zero point 0.7. This is for the first record. This is for the first record. For the second residual, for the second residual again minus zero point 0.7. For the second residual zero point 0.7, my prediction is zero point 0.7 multiply 1 minus zero point 0.7. Just I calculated this weight by using this formula. Okay, just I got minus 3.3. Similar way I want to calculate the weight for this leaf of the residual. Zero point 0.3, this is my zero point 0.3 is my numerator. Denominator is previous probability. Zero point 0.7 multiply 1 minus zero point 0.7. Then I got the weight of 1.3 by using this formula. Similar way minus 0.7, this is my residual, this is my sum. So residual divided by zero point 0.7 divided by zero point 0.7 multiply 1 minus zero point 0.7 previous probability. Similar way I calculated the weight minus 3.3. Similar way for the two residuals, zero point 0.3 plus zero point 0.3, two residuals just I added. For the two times I need to add my previous probability. Previous probability 0.7, 1 minus zero point 0.7. This for the first residual. This for the second residual, zero point 0.7 multiply 1 minus zero point 0.7. Okay, here if you see for the two residuals zero point 0.7 also I got the weight minus 3.3. For one residual weight also I got minus 3.3. Okay, to average our residuals we are using this formula, weight formula. Okay, for in case of for example we have 10 residuals also in this sleeve, then we will get the same weight by using this formula. Okay, similar way I just calculated the weight. Okay, this weight by the use of this weight we are calculating the prediction as well as the next decision tree prediction. Okay, next decision tree residuals also we are calculating by using this weight. Okay, let us see how we are calculating the uh, as of now we calculated until here model 1 is done. Now we'll discuss how the model 2 probability, how we will calculate the probability, and also for the model 2 how we'll calculate the residuals. Okay, here similar way I need to calculate the log odds here, but we have to use other formula, current leave residual. Let us calculate the record 1 probability. I know the residual of record 1 minus zero point 0.7, current leave residual, okay, minus zero point 0.7, this is my zero point 0.7, plus learning rate is a constant throughout our model. Okay, learning rate, the range between 0 to 1 we can mention any value. I am taken for the 0 0.2 as the example here. 0 0.2 multiply here weight of the here minus zero point 0.7. What is my record weight is minus 3.3. Just I mention my weight here, then I will get the log odds. Then we need to convert into the probability, this log odds. Just I am calculating the probability here, e power 0.37 divided by 1 plus e power 0.37, then I got the 0.2 probability. Okay, this 0.2 probability I got. Similar way 0.7 residual I got 0.2. Similar way minus 0.7 residual I got 0.2. For these three records I got the probability. Similar way I need to calculate the probability for the zero point 0.3. Okay, this is my residual, current leave residual. For example, this is my residual, third residual L. L is my third residual, zero point 0.3. 0.3 plus learning rate is a constant, zero point 0.2. What is the weight of this leave? 1.4 is my weight. I just calculated, I got 0.58. And probability I'm just this is my log odds. I'm just this is my log odds. Similarly I calculated here. Okay, I just calculated for the second log odds, and this is my probability for this second log odds. Okay, e power 0.58 divided by 1 plus e power 0.58, then I got zero point 0.6. This is my second probability. For all other zero point 0.3 I got zero point 0.6. Okay, this is my for zero point 0.3 residual. If I calculate using this formula weight, what is my current residual plus learning rate multiply weight, then I will get the probability of the next model. Okay, I got the model 2 probability. Okay, zero point 0.2 and zero point 0.6. Now we'll calculate the residual for the model 2. How we are going to split? Okay, here actual minus residual, 0 minus zero point 0.2 minus zero point 0.2, again 0 minus zero point 0.2 minus zero point 0.2, 1 minus zero point 0.6 zero point 0.4. Similar way 1 minus zero point 0.6 zero point 0.4, until here the same zero point 0.4. The last one 0 minus zero point 0.2 minus zero point 0.2. Okay, this is my actual minus prediction, or actual my probability, nothing but prediction. Actual minus prediction, I got the residual for the second model. Okay, similar way this is my model 2. Okay, model 2, let us see here. Okay, less than 20, this is my three records. Okay, this is my residuals. Okay, less than 20, my x2 is high, x2 is high, then these two records minus zero point 0.2 zero point 0.2. If it is low, zero point 0.4. Okay, just I have mentioned all the residuals here. Similar way for 20 to 30 I got 0 0.4 0 0.4 0 0.4, similar way. Okay, and the last three records 0 0.4 0 0.4 and zero point 0.2. Okay, just I mentioned all the residuals here. Okay, for the all the leaves. Okay, next we need to calculate the weights. For example, here 0.2 plus zero point 0.2 for the two residuals, sum of two residuals in the leaf, divided by previous probability. Here is a probability of 0.7, multiply 1 minus zero point 0.7 plus 0.7 for the second residuals, zero point 0.7 multiply 1 minus zero point 0.7. This is zero point 0.4 is my residual, divided by previous probability 0.7 multiply 1 minus zero point 0.7. Similar way, one residual minus zero point 0.2 divided by 0.7 multiply 1 minus zero point 0.7 for the previous probability. Here I need to sum all the residuals. Zero point 0.4 plus zero point 0.4 divided by, for the first residual 0.7 in multiply 1 minus 0.7 plus 0.7 multiply 1 minus zero point 0.7 for the previous residual. Just I calculate the weight minus 1.3 for the, for two residuals also I got 1 point minus 1.3. Similar way, minus 0.2 I got 1.3. For the two residuals also I got the same weight. Similar way, for the one residual or two residuals also I got the same weight. Okay, I am using this formula to get the same weight for the multiple residuals. Okay, now I know how to calculate the residual for the next tree, and also I know how to calculate the weights also. Now I have the new data, I have new test data. Then we'll see how to calculate the prediction. Okay, prediction for the new data. For example, if my x1 is greater than 30 and x2 is high and x3 is e, and what is my y, whether it is true or false, whether it is 1 or 0. Just I want to calculate using the formulas. First we need to calculate the log odds. This is my base prediction is zero point 0.7. This is my base prediction is zero point 0.7. And the model 1 learning rate. Okay, learning rate always constant, zero point 0.2, zero point 0.2, everywhere is zero point 0.2. And the weight of the first model. Okay, here if you see x1 is greater than 30, I will come to x3. What is my x3 is e means minus zero point 0.7. What is my weight at this point? Minus zero point 0.3. Okay, here for the, I just calculated the model 1. Here I need to sum learning rate multiply weight. Zero point 0.2 multiply minus 3.3. This is a model 1 I got, minus 3.3. I got the model 1 learning rate and weight. And similar way, I need to go for the next iteration also. For the sequentially, I got this one. For the second iteration also, the learning rate is constant, zero point 0.2 multiply minus 1.3. Similar way, if x1 is greater than 30, I will go to here. And if it is x3 is e means here minus zero point 0.2. What is my weight? Minus 1.3. Just I calculated this much. Let us take, we'll get the log odds. That log odds we need to replace into the probability equal to e power log odds, whatever the value we need to replace here, e power log odds divided by 1 plus e power log odds. Then I got the value of 0.46. If I calculate this probability, then I got the 0.46. This 0.46 is the less than zero point 0.5. In our logistic regression, if it is less than zero point 0.5, the prediction is 0. If it is greater than zero point 0.5, whatever the probability, then we need to mention it as prediction is 1. Right now my prediction for this new data is 0. In case of any further data, we need to calculate the same. Base prediction is the same. And let us take, we can take the another weights also. We have to just calculate the same way. If it is x1 is greater than 30, then we need to go to the second one, x3. X3 is my e. Then what is the weight? Just we need to take the same weight, and the learning rate is the same. For example, if my route is this way, then I need to take this weight multiply learning rate. Similar way, if my route is this way, then I need to take this learning rate. Learning rate is a constant, zero point 0.2, and I need to take the weight. Based on the weight and learning rate, we are getting the prediction. And finally, we need to calculate our probability. If it is greater than zero point 0.5, then my prediction is 1. If it is less than zero point 0.5, prediction is 0. This is a way we are calculating our prediction as well as training in our uh, gradient descent boosting. Okay, we'll see the difference between ADA boost and gradient boost. Okay, here increase the weight that are misclassified before. Okay, whenever the records are misclassified, we are going to increase the weight and we are passing to the next iteration for the ADA boost. In case of gradient boost, we are optimizing the loss function. Here, as we discussed in the previous example, we are reducing our loss in each and every iteration. Then we are trying to achieve our actual and target should be matched. And here we are using the stumps will be used for our training and also prediction, mainly one root and two leaves. Here leaves up to 8 to 12, as we discussed here. How many leaves? 1 2 3 4 5 leaves here. Okay, here up to 8 to 12 leaves we can build our decision tree. Similarly, based on our data set, we used to build. Okay, let us go for one example here. I'm taking one example data set. This data set I will try to train and also predict using the gradient boost algorithm. Okay, here I have the kyphosis one y column and three x1, x2, x3. Okay, three independent variables, one dependent variable. This is my x. This is my x. Three columns are x. This is my y. Okay, first we need to divide into the two parts, and after that we need to divide into the four parts. Okay, if it is my x column, okay, we need to divide into the two parts. Train data is my 70%, the above one, and remaining one is a test data. Okay, here for the training data, if my column is x, I'm mentioning it as x train. If it is my column is y, I'm mentioning it as y train. Similarly, if my column is y, I'm mentioning it as y test. Similar way, if it is my y column, I'm mentioning it as x test. Okay, here I just divide into the two parts, train data and also test data. If it is my x column, I'm mentioning it as y train. If it is my x column, x train. Similar way, if it is my y column, y test. And similar way, if it is my x column, x test. Okay, here I divide into the four parts. If I want to train our model, I need to pass the x train and y train for our model training. If I want to test our model, we need to pass the x test, then we'll get the y prediction. Then we'll calculate the accuracy between the y test and y prediction, then we'll get the efficiency of our model. Then similar way we'll execute in our Jupyter lab. Okay, this I already executed in the Jupyter lab. I export it as HTML, that I am explaining it here. Gradient boost descent classification, gradient boost. Okay, here import the libraries. Okay, here I'm importing pandas as PD. If I want to read any Excel, we need to use this import pandas as PD. Here dataset is my object equal to PD is my pandas is my alias name dot read csv is my method. I am accessing my kyphosis.csv. Okay, here I accessed complete my data set. Dataset dot head, I'm just representing first five records. If you see here, first five records are absent, absent, present. Okay, here also if you see absent, absent, present. Okay, same data set I have accessed here or not, just we are confirming with your head command. Okay, I got the x1, x2, x3 and also kyphosis. Similar way, I'm doing the data pre-processing. What is my x? Dataset dot drop, I am dropping this x column, kyphosis column. That remaining I am mentioning it as x, and my y is my only kyphosis column. Just I just mentioned this, my kyphosis is my x, and the remaining x1, x2, x3 are my x. Okay, this is my x, this is my y. Just I printed x. What is my x? Age number start, all the rows I just printed. Similar way for print y means or absent or present I printed here. Okay, similar way, now I got the data set into the two parts. What is my y, what is my x, I divided. Okay, next after that we need to divide into the four parts as we discussed here. For the training data, I need to divide into the x train and y train. For the test data, x test and y test. Okay, similar way we need to divide using the one of the method here. From scalar model selection import train and test split. Here I am using this method for the splitting the data. I am just passing my x age number start. I'm passing this data complete three columns, and what is my y, kyphosis, and my test data. Test data I'm mentioning it as zero point 0.3. That means train data is zero point 0.7. Okay, remaining is zero point 0.7. Okay, similarly I just divided as per our requirement. And here random state I mentioned it as 10. It should always initialize with something, otherwise we'll get always different prediction. To get the always constant prediction, we need to initialize this random state with some value. And here I got the x10 and x test, y10 and y test. I got the four parts from scalar and ensemble. This is a gradient boosting is one of the ensemble techniques. That's why I'm using this from scalar ensemble import gradient boost classifier. From sklearn import accuracy matrix. If you want to calculate the accuracy of our model, we need this method. Okay, here model gradient boosting equal to gradient boost classifier class I'm accessing model gradient boost dot fit. I'm just passing my x train and x test, x train and y train I'm passing to train our model, X train and Y train to train our model. Okay, just I am passing this X train and Y train to train our model. Okay, here I am using the mainly loss function deviance means mainly logistic regression we are using for our residual optimization. Okay, here next we'll go to the prediction. I my model training is done by using this method, and similar a model gradient boost dot this is my object dot predict is my method. I'm just passing my X test. If I'm passing my X test, then I will get the Y prediction. This is my Y prediction. Okay, once I got the Y prediction, then I can calculate the accuracy between the what is my Y test and Y prediction. We'll calculate the accuracy now. Okay, here I'm using a confusion matrix. I want to display how many records are correct, how many records are wrong. If I want to display, we need to use the confusion matrix. Again, I'm using the pandas pd dot cross tab. This is one of the function. It will display the confusion matrix. Okay, here y test and y prediction we need to pass. What is my actual data? What is my prediction data? This is my row I am representing with the actual data. Columns I am representing with the prediction data. This is my predicted. This is my actual. Here I am just whatever the matrix I am representing using the graphical view. I'm using the import cmon as sn dot heat map. I'm just passing my confusion matrix here. Just I am mentioning with different colors here. Okay, here if I understand here, these my rows are actual, prediction are these columns. Okay, actual is option 16 and also prediction also option 16. Okay, these two are correct prediction, and actual is present 5 and prediction also present is 5. Okay, these two are correct predictions. For example, this is the actual is present but the prediction is absent. This is a wrong prediction. Actual is absent and prediction is present. Okay, this is also wrong prediction. Okay, these two are wrong prediction, these two are correct predictions. 21 predictions are correct and 4 predictions are wrong, but my actual or prediction are wrong. That's why 21 divided by 25, then I will get the 84 accuracy. Accuracy score, I'm just passing the y test and y prediction. Similar with 21 divided by 25, then we'll get the 0.84 accuracy. Okay, this way we can calculate the accuracy by using this gradient descent boosting. Okay, here we by using one data set we had been trained and also tested. Thank you for watching, friends. Thank you.